So, just a reminder before we start the examples, the zero and negative exponents idea here. Any non-zero number to the zero power is the number 1. Again, 0 to the 0 power is undefined. Negative exponents. So here the exponent has to be an integer. The other number doesn't have to be. And if I have that number a to the negative whatever power, it becomes 1 over a to the positive of that power. By the way, the reverse is true. If I had a to the negative n in the denominator, it would push it up to the numerator. But we'll get to that property later, but just so you kind of understand where we're going with this. 7 to the negative 3 is 1 over 7 cubed, and then you'd go ahead and cube the bottom. Negative 5, notice the parentheses forcing the entire thing. To the negative 2 is 1 over negative 5. Again, the whole thing in parentheses squared. So this would be 1/25 here in this case. So, what is the simplified form of each expression? Here again, here's the first example. 9 to the negative 2. Again, that negative 2 forces the 9 to the bottom. The negative does on there. Makes it 9 squared down below. So 1 over 9 squared, which is 1 over 81. And here again, any non-zero number to the 0 power, notice here the negative goes with it. It becomes 1. The reason I bring that up is that if I gave you negative 6 to the 0 power, that is technically, remember the 0 only really applies to the 6, not to the negative part of it, unless you use parentheses like here to force it. So this really becomes negative 1 in this case. So be careful of that difference. I will try to trick you with it, and you know it. And then the got it's here will actually appear on the next page. Here we have your got it. 4 to the negative 3 becomes 1 over 4 cubed, which is 1 over 64. 4 times 4 times 4. Negative 5 to the 0 power is going to be 1. This becomes 1 over 3 squared, which is 1/9. This becomes 1 over 6 to the first power, which is really just 1 over 6. And this becomes 1 over negative 4, the whole thing squared. And negative 4 times negative 4 is a positive 16, so 1/16 in the end there. Alrighty, so here we have, again, simplifying an expression, so stringing all this together. So watching here, 5a cubed b to the negative 2. The 5 a cubed stay up top basically. This becomes 1 over b squared, and then that transfers that b squared to the denominator. So 5a cubed over b squared. When we say simplify an expression, what I mean is you have no negative exponents left. So it's kind of a rule of simplifying these. No negative exponents left. 1 over x to the negative 5. Now again, the same kind of thing applies. This forces the x to the negative 5. The negative on the 5 forces it up. So it really becomes 1 over, basically pushes up to the top. Let's just say that. So it becomes x to the 5th power. So, if you have negative exponents in the denominator, it pushes it upward. If you have negative exponents in the numerator, it pushes it downward. I mean, that's a simple way to think about that. All right, so your got it's for this. X to the negative 9th power is 1 over x to the 9th. It's just the rule. This one, if you think of the negative in the denominator, negative in the exponent of the denominator, there we go. It pushes it up, so it makes it n cubed. That's not really a very good n, but n cubed. There, that's a better n down there. And here, this one, a little more convoluted. So we get 4, right, and b, and in the bottom we push the 3 cubed. So again, the negative of the exponent here forces it to the denominator. This one, because I have a negative in the denominator, it forces it up. So 2a cubed is what we get there. And here, there's a negative in the negative exponent in the numerator, pushing that n to the 5th down. So we get 1 over n to the 5th, m squared is still sitting there. Or alternately, like they wrote it here. So again, I did mention that you should need to learn the rules here. And that's really what this part's about, learning the rules. You can do it the long way. Look at that last slide and look at all the division stuff you have to go through and all that. But again, learn the rules. Like with anything else, at some point we're going to have to evaluate these things. In other words, put numbers in for them, right? So a little bit of practice at that. If I put in a 2 for s, a negative 3 for t, we take a look here and just substitution, right? So where we see, and you can do it either way. You can substitute first, like they do in this method 2. I kind of like that one. Plug in the 2 for the S and the -3 for the T. Please remember there's a negative here with it. With your integer, make sure you put parentheses around to help it. Make sure you don't lose it when you work with it. Otherwise, you might be tempted to throw the negative on afterwards. So, in this case, we notice here this -2 forces the -3 to the denominator. In the top, 2 cubed is 8, times 3 is 24. -3 squared is a +9, so 24/9, or alternately mixed number 2 and 2/3. Otherwise, here in this case, we move it around first. Move the t to the denominator first, leave the s up here, then throw in your numbers and work it through. Either way, you notice this line's the same. You're going to get the same answer. So it doesn't matter if you move them around before or after you substitute. Here we're going to substitute for n a -2 and w of 5. So let's get started with that. This first one, again, n is -2, so I'm going to throw parentheses around that. So I'm going to have -2 to the -4th power. And then I'm going to have 5 to the 0 power. Well, that 5 is going to become a 1, right? And that's also going to throw, this negative exponent is going to throw that in the denominator. So I'm going to have -2 to the 4th power. Well, I multiply that out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So again, it's positive, so I get positive 1/16. There's the first one. Second one, let's move it around first before we throw in the numbers. Why not, right? So for B, we're going to have 1 over nw squared, and just the w is squared there. And for n is -2, so 1 over -2, and w is 5, so 5 squared. So I'm going to have 25 times -2, so I'm going to have 1 over -50, or -1/50 if you prefer. Okay. For C, well, the end of the 0 is obviously going to become 1 right away, but so you can even make that before you even substitute. It's up to you, really. But 1 over, and then 5 to the 6th power. And 5 to the 6th power is 5 times 5 times 5. And then, 5 times 5 times 5 times 5. And we're going to get 15,625. So 15,625. And then the last one here, we're going to have 1 over n, and then w is to the -1. That means that w gets thrown up top, so I've got w over n, and let's see, n is -2, and w is 5, so I'm going to get -5 halves in that case. Part E, is it easier to evaluate n0, w to the 0 power, for n equals -2 and w equals 3 by simplifying first, or by substituting first and explain? I'd say simplify first, because it automatically makes them both 1, and 1 times 1 is 1. No work, don't even have to substitute it. So our fourth problem, yes, we can make story problems out of these too. I know you love it. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. So that's where they start, right? Evaluate the expression for h equals 0 and h equals -3. What does the value of the expression represent in each situation? So here's the idea. Maybe you figured this out. Technically, I'm starting with 1,000 because if I put in 0 hour, this makes 2 to the 0 power is 1. Right? And 1 times 1,000 is 1,000. So at 0 hours, I start with 1,000, I don't know, microbes, whatever they are. And if I plug in a -3 here, you technically get a time machine. You get that? You're going to take your 2 to the -3, that's 1/8, times 1,000 is 125. So you just got a time machine that if you go back 3 hours, it gives, you said we started out with 125 there. You had 125 at that point instead of 1,000. So, I always tell you, you don't have actually have a time machine in math. Guess what? You now have a time machine. So here we have a similar problem. A population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the w, where w is the number of weeks after the population was measured. So here, obviously, when we first measure it, start thinking to yourself, 3 to the 0 power, that's the starting point, right, is 1. 1 times 5,400 is 5,400. So when I first measured it, I got 5,400 of whatever they are, insects. So evaluate the expression for negative 2, 0, and 1. What does each value represent? So I'm going to talk about that first, what each value represents. The 0 in here represents my starting point, 0 weeks. Negative 2 represents going back in time to what the population was 2 weeks ago. 1 represents the population 1 week from now. Okay? So, and again, the way we fill those out, so we're going to have 5,400 times 3 to the 0 power. We're going to have 5,400 times 3 to the negative 2 power. And we're going to have 5,400 times 3 to the 1 power. And so here, this is obviously just going to be 5,400. Didn't leave a lot of room for myself to write. So that's the point where you started out, right? Here at the negative 2, so you're going to have 5,400 right, divided by 9, which is going to be 600. Right? And again, how did I get that? That's 5,400 divided by 3 squared because the negative force the denominator, which is 5,400 divided by 9, which is 600. So that was what the population was 2 weeks before I measured it. Again, according to the model we're using here. And this then is going to become 5,400 times 3, which is 16,200, which is what the insect population will be in 1 week. That thing grows pretty quick. And you're going to, if you go to graph this, you're going to find something like this. By the way, at no point is this going to become a negative number because you can't have negative bugs, right? Just a reminder what we've been talking about here, the 0 and negative exponent properties. Again, anything except for 0 to the 0 power is the number 1. And if you have a negative exponent, it forces it into the denominator. If you have that negative exponent in the denominator, it forces the number into the numerator. And don't forget if you're dealing with a negative number, for instance, negative 6 to the negative 2 power, right? Use the parentheses because that's 1 over negative 6 squared, as opposed to negative 6 to the negative 2 power, which is going to become negative 1 over 6 squared, because only the 6 goes with it unless parentheses force otherwise.